Good morning. Today we are going to see about the electromagnetic induction, right? When a bar magnet is being brought close nearer to a closed circuit which is attached to a galvanometer, the galvanometer will show a deflection, right? It is having meaning that galvanometer only deflects when there is a current flow in the coil. So when we move away the magnet, the deflection becomes zero. There is no deflection meaning, right? So it was clearly understood that the bar magnet and the magnetism and electricity being combined together here and producing a voltage that is known as electromagnetic induction. How many ways it gets affected is that the thing we have to now discuss. Let we have two circuit, one with all two circuits are closed circuit, one attached to a galvanometer and other attached to a switch and a battery. When the switch is on, the current starts to flow through the circuit which is at the bottom, which makes to deflect the galvanometer at the top, meaning even though the coil doesn't move, there is a deflection in the galvanometer, right? This is one thing, meaning current transfers through others. Second thing is by moving the magnet in and out of the coil. Here the magnet is moving up and down, but when you have number of turns is less, even though the turn is less, the magnet moving up and down shows deflection of the electromagnetic induction. But if you increase the number of turns, the galvanometer deflection is higher. When the large number of turns are there, the deflection is very large, meaning the number of turns is directly proportional to the current passing through the coil or the voltage produced. It was defined by the formula E is equal to N into d pi by dt. E is the induced EMF, N is the number of turns in the coil, and pi is the magnetic flux produced, and T is the time in seconds. Okay, this is one set. Third experiment he discussed by the magnet, keeping the magnet stationary. In the second part, magnet will be moving up and down. Here the magnet will be stationary, only the circuit will be moving up and down. But the speed of the circuit, that is moving up and down motion, when it is faster, the magnetic induction is higher. Electromagnetic induction is higher in the galvanometer. So he concluded whenever there is a change in the magnetic flux in a closed circuit, an EMF will be induced. Okay, the EMF produced in this phenomenon is known as electromagnetic induction. It should be a closed circuit, one thing, and it should have a connected to the magnet. These are the two things to remember. The number of coils determine the magnetic flux electromagnetic induction.